See what it says, 92% correct. Howdy everybody, Steve here, KM9G. Today we're going to build the Morse code trainer using the Kaiweets USB powered soldering iron. Let's get to it. A new kit to build today over here from Sparkgap Labs. This is the Morse code trainer and we're going to use a new soldering iron over here. And I'm going to see how well it compares to the Pine Sill. So I guess first thing we got to do is get the soldering iron out of its packaging. It is a USB powered soldering iron. Instruction manual, multiple languages. Where's the English part end? Right there. So 7 pages of instructions, but it's a soldering iron. How much do you need? There is the soldering iron itself. That looks pretty cool. It's got a little spot there for holding it or to make sure your fingers don't slip. Down onto the fry and bacon part, we have a power brick. This is actually kind of a bit heavy. I wonder why it's so heavy. So it's got USB A and USB-C on it, and it says USB-A power out is 5 volts, 2.4 amps, USB-A plus Type-C is 57 watts, and the USB Type-C can do all the USB Type-C things, 5 volts, 3 amps, 9 volts, 3 amps, 12 volts, 3 amps, 15 volts, 3 amps, 20 volts, 2.25 amps. That's heavier than it should be, so I guess that speaks to its quality, because usually these things weigh like nothing, making you think there's nothing in it. There we go. Bunch of accessories. There we go, look at that. It comes with a nice set of tips. So we have the K65 tip, lead-free soldering iron, lead-free soldering iron tips, lead-free soldering iron, lead-free, lead-free, lead-free. So these are all lead-free tips, but I'm going to use it with leaded solder anyway because that's all that I have. So you have a chisel tip, a wider chisel tip, a very tiny point, a normal size point, a pretty fat tip, and then a somewhere between fat and skinny. I am going to take this one here in the middle and stab myself with the one right next to it. That was fantastic. It has a little rest. That's cool. And the rest has a little sponge. That's cool. I'm not really a sponge user, but I don't, you know, to each their own. It has a nice cord keeper on the cord. And then this is a heck of a USB cord. It actually feels like it's a power cord. I mean, that's technically what we're using it for. Cardboard from the box. So the tip, let's put the tip in, see if this is obvious or non-obvious. All right, well that was obvious. It just slides right into place. So that goes all the way down to a notch on there to stop it, but you don't need to screw or unscrew that. And then as far as transportation goes, that's what that part there is for, is to cover that up. And that feels like either really hard plastic or, yep, this is aluminum. So it'll have a little bit of heat dissipation to it as well. And then that is positively locked on there. Let's pull the cover off of the screen. Oh, these things have been getting more and more finicky lately. Usually what I've been doing lately is just peeling the tab off and not peeling the screen protector off. So the screen protector is still on there somewhere. Let's take a look at the stand real quick. So I would use the stand like that, or possibly like that. But if you turn it around and use it like that, you run the risk of maybe connecting it somehow to the plastic. No, it looks pretty good. So yeah, you could use it like that, but I would use it like that. And you have that little bump there to stop it from sliding off in either direction. And then it is non-heat to metal part as opposed to heat to metal part, which would then conduct into the plastic and might make you unhappy. Let's get her plugged in. All right, that is plugged in. And then the iron is waiting for further instructions. All right, it is in Celsius and it's heated up pretty quick. So I can change the temperature. We'll try it at 300 and see how far we get on the project. And then it's starting to even out. Yep, there we go. Now it has evened out. Let's put that out of the way and let's take a look at our kit that we're going to build with it. This is the Sparkgap Labs MCT Morse code trainer. So there is your Sparkgap Labs side and there is your QR code for instructions there at sparkgaplabs.com/support. And I will show you these instructions. These are actually fairly amazing instructions. Put the box out of the way. There is what the case will look like, and the case has all of the parts included in it. So this is pretty high quality PCB material, it looks like. We get a display screen, bag o' parts, 9-volt battery holder, 9-volt battery holder jumper wire with a JST plug on one end, speaker so you can hear what's going on, piece of what I call blue tack or glue tack. This will hold stuff down while you're soldering with it. And then the case. This is a nice metal case. And this is serial number 136, Marblehead, Massachusetts, made in the USA. Holy moly, that's a lot of parts. A couple of ICs there, a couple of IC sockets. The first instruction is to install the IC sockets on the back of the board. So there's a couple of IC sockets. And when you guys install IC sockets, on the socket itself, there is a little notch right there on this side. And on the circuit board, the white text is called a silk screen. Some of y'all know that, some of y'all might not. But there is also a matching notch there. And the goal is to line up the notches, like so. For solder itself, I use Kester 6337 solder. This is leaded solder. I'm living on the edge, I'm living dangerously. But I like to live on the edge because I do not like the lead-free stuff as much. It doesn't work the same way. And so what you can do to make your life a little easier is take some of this blue tack stuff here and break it into a couple of pieces. And then you can use that to hold your piece down to your work where needed. Sometimes you need this, sometimes you don't. I will use it sometimes throughout the project and other times not. Take my solder and I'm going to tack down 2 corners of this. Get a little solder on our tip, and then let's find the first pin there and the last pin there. And then what I do is I take this blue tack or glue tack off and set it off to the side somewhere where it's not going to pick up a lot of dirt. And then I check my work to make sure that that socket is all the way down. And it looks like it's a little tiny bit up. So what I'm going to do is I'm going to apply some pressure with my thumb and reheat the pin, which will let me push that through all the way. And the blue tack did a really good job, so I don't have to go very far. And now we have a nice flush mounted IC socket. So let's do it again 2 more times. This is for the CPU, and then this is for the amp. You can plug that in, get that nice and stuck on there. And then before I settle that one into place, I'm going to do this other one at the same time. All right, those all look good. Now I'm going to go back and put all those pins in place. You got this. Then check your work because it looks like I missed a pin. All right, looks good. All right, next we need a 5-volt regulator. So U1 is right there. It looks like it's a transistor package. And BT1 is right there. So I need this, and I need a 5-volt regulator. And that looks like a 78L05 right there to me. And if I wasn't 100% convinced, it's also the only 3-pin transistor package here. That's the one. All right, so these are also very carefully marked. This has a shape to it where it's round on one side and flat on the other. And the circuit board has an outline that is round on one side and flat on the other. So we put our 3 legs through the 3 holes and push it down as far as it can until it gets to be a pain for you to do. Doesn't have to be all the way down. And then that will spread the legs out on the back side and it'll hold itself in place. And then we have this connector here, which is our battery connector. And when you put it in, you want to make sure that it fills up the little silk screen on the circuit board instead of having any gap left over. So this is the wrong way. That's the wrong way. Let's turn it around. And that's the right way. So you don't have any gaps in your silk screen. And this one here is going to need a little bit of that tacky stuff again to hold it in place. And then you just come back with your flush cutters and cut that. Still working on the back side of the board, we need to install ISP header, 8 resistors, the diode, and the trim pot. Get some of these parts a little closer together. J4 is right there in the middle of the board. Mount that up. All right, that looks really good to me. I'm going to add a little bit of heat to my soldering iron. take it up to 340 Celsius. And we're right there, done. Nice and fast. The reason why I did that, you can see all of this brighter green part, that is your ground plane, and this corner pin right here connected to that entire ground plane. So when I'm using the soldering iron here to heat up the board here, what's happening is all of my heat is dissipating all throughout that ground plane inside of the board, and so I just wanted some more heat. I could have dwelled a little bit longer, but the goal with soldering is to get in quick and get out quick and not burn up any of your components. Normally I run at about 640 degrees Fahrenheit, which is somewhere around 300 degrees Celsius, and I just boosted up the temperature a little bit to compensate for that heat spreading ability there. Now I need 8 resistors, R1 through R8, and for me, I find it easier to use a multimeter. So I'm going to get out my Kaiweets KM601 multimeter. And I like this because it's got a fancy color screen. And then I want to measure a resistance, because to me, all of these resistors pretty much look exactly the same. You can kind of suss out real quick that the R2 and R5, which are 2 of the same kind, these are 10 kilo ohm resistors, are going to be there in that 2-pack. And then R3, R4, and R8 are 1 kilo ohm resistors, and that's another 3-pack. So that is the process of deduction right there, and that leaves me with these 3. You can barely even see them on the camera when I put them down here. That's how small they are. So I need to take these guys and figure out which one is which. And so what I do is I take my multimeter and I set it to ohms, and that's 1 kilo ohm. So that's not it. That's 470. That is it. And just to be safe, this is 10 ohms. So it is this one right here in the middle. 470. So I'm going to take this one and I'm going to install it. And we're still working on the back side of the board. R1 goes right in the middle. They do make fancy resistor bending tools, lead bending tools. I do not have one of them. They also make a 3D printed version of it that you can print yourself if you've got a 3D printer. I do not have one of those either, but I have a 3D printing friend, R1. They don't have any real orientation when you put them in. They resist equally in both directions, so it doesn't really matter. What I try to do is I try to line them up so that they have the same color band arrangement, because it makes the person who comes in after you a little happier. I'm going to look for 1.2, which I think is this top one here. Yep, 1.19 is close enough to 1.2. And that's one of the other things that you're going to find is that all of this stuff is close enough to get the job done, and none of it is entirely 100% accurate. If you want 100% accuracy, you spend more money. R6. And it's not that the case, not that the kit isn't good, it's that it's just not necessary for the successful operation of the kit is over here. And then on the back side, I'm just spreading these legs out in order to hold the piece in place until I get the rest of them installed. R7 is the next single piece, and this is supposed to be 10 ohms. And since it's the only one left, it's pretty much guaranteed to be 10 ohms, but we're going to check it out anyway because we can. And there it is. It was almost 10 ohms there, dead on for a second. Now it's 9.7. That is just fine. And you can put as many of these in as you feel comfortable putting in before you start doing your soldering. All right, so now I need R2 and R5 are 10 kilo ohms, and it's a 2-pack, so it's probably these 2. But I'm going to double check it anyway. 10 kilo ohms. All right, these are the ones. These are they. And then these are the only ones left, so I really don't need to test them because I don't really have any choice. They're either going to work or the whole thing's not going to work. And this is R3, R4, and R8. All right, they all passed the pluck test. Diode, and there's only one diode on the table, so that must be the one. Diodes, I have been instructed, true or not, it's just what I've been instructed, that they don't like heat so much, so I try to get in and get out quick with these. And they have a little stripe on the part itself. And if you look at the silk screen on the circuit board, you can see that there is a matching stripe on the circuit board. So you want to make sure that the stripes line up, and then you know you have the diode going in the right direction. Because diodes are designed to pass voltage in one direction and not the other. So it's kind of a gatekeeper. And then we need a trim pot, RV1. And that's the only part that looks like a trim pot to me. And there's the only spot I can see where a trim pot might go. and it only goes in one way, so you can't get that wrong. And those already have enough tension on them to hold them in place. All right, looking good. What's next? We have 3 box type capacitors. You can tell by looking at the PCB diagram that he's got on the instructions there which one goes where. And these don't really have an indication of orientation, so I'm going to put it with the writing on the capacitor in the same direction that he's got on his diagram. And then with these, you can just cut these right out of the cardboard. Electrolytic capacitors, C1, 2, 3, C5, and C8. All right, here is a gotcha. There are 3 of these. There is 1 of those, and there is 1 of those. However, 2 of these are one type, and 1 of those is another type. So these 2 are 47s. It's written right on them. This one is a 10. This one is a 0.33. And this one here is a 220. So to reduce confusion, we're going to do C1 and C3 first, which are the 47s. C1 and C3. And then these guys have a stripe on them, which is the negative side. And then there is a stripe on the board. So I'm going to bet that they line up that way, which in fact they do. And if the striping wasn't enough for you, they also have one leg that is longer than the other to indicate which side is positive and which side is negative. All right, C2 is the 0.33, which is this one right here. And then C5 is the 10, which is this one. And then that leaves only one left. And the footprint on the board is sized up to match this extra beefy, extra big capacitor. Let's get them all soldered in place. So the LED comes with a spacer on it already, which is necessary to get it to line up with the case. And we need to install the speaker. So we finally get to flip the board over, and we are looking for D2. And on LEDs, they have a flat side and a round side, if you can find it. Right there is the flat side. And they also have the short leg, long leg thing going on to help you out. And that's a little wiggly when you put it in. So I'm going to spread the legs to give it kind of a better anchor there. Speaker has a positive and minus indicator on it, and there is a positive indicator on the circuit board. And this doesn't lay flat, so I just engineered a way to make it lay flat. I'm going to tack down one side of the LED. I'm going to get these guys here done on the speaker. And then I'm going to check to make sure the LED is the way I want it to be, and we can get the other side of the LED done. We need 4 switches and the 2 stereo jacks. So these are my 4 switches. And these are my 2 stereo jacks. And out of these switches, one of these is a little different. So that one latches in the down position. So that is my power switch, and then these 3 are momentary switches. So you push them and they just spring back. All right, those are all set up right. So let's put in the black switch. And there's nothing that's going to hold that in place, so we need to use some blue tack. And I will do these one at a time. And I'm going to put down just 1 pin on each of these, and I'm going to check my work. Next is red, and then green, and then 2 audio jacks. And these audio jacks have nice big holes in them. So you want to put in more solder than normal. But again, we're going to start with just 1 pin first. 1 pin only. All right, these all look pretty good. The reason why I do 1 pin only, these each have 6 pins holding them in place, and then the audio jacks have 5 pins holding them in place. And if I put all 5 down and it was crooked, then I would need to heat all 5 back up and keep them all hot all at the exact same time in order to move the part around. And that's just not how physics works. It's very easy to do it with just 1, and then that actually welds it in place. And then when you're doing these topside jobs, make sure that you're not rubbing against other parts that you're trying to not melt, like these tall capacitors that are nearby, like a doctor. At first, do no harm. All right, so that should be all 4 switches and both audio jacks. Check my work. I feel like I missed a pin, so I'm going to go ahead and touch that up again. Install the chips. All right, just like the sockets have that little notch in them and the silkscreen has a little notch in it, the chip also has a little notch in it right there. We need to make sure that all of that lines up. And then the chip, usually when they come from the factory, they're a little bit more open. And again, they make devices to squeeze these chips into the right form. But if you're careful, you can do it right with the bench. And then I make sure that all of my pins are in and my notch is in the right position. And then we shove it all the way in until it bottoms out. And then which one of these is which? The amplifier, I figured it'd be an LM386, which is this one right here. And that goes in the top socket U4. That goes in the top socket U4. Check to make sure all the pins are lined up the way they're supposed to be. And that one was bent a little bit, so we just unbend it. All right, that looks good. Last chip is the DAC chip. All right, chips are done. I do not know how good or how bad this battery is. So step number 1 is going to be to test its power output, and we are at 8.9 volts DC, good enough to get the job done. Battery power connector, and plug it in. And let's orient this the same way that he's got it on the screen. And he says, turn it on, so make sure it's in the squashed position. What we're doing is we're going to test. We should see the LED light up and we should hear a beep from the speaker. So I'm going to put my negative wire on, my negative terminal, and then we're going to touch. All right, I'm getting a weird sound and my LED is not LEDing. So when we last left off, we were doing a test where you connect the negative terminal of the battery and you want to quickly connect the positive terminal of the battery. And I don't know if you can see it or not, but that's blinking. And I know you can't hear it, but it's going tick, 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 tick in time with the blinking. And I went and checked over all of my solder joints, and as you can see, they all look pretty good. And it's a two-sided board, so I did everything on the other side as well. And I even went through the trouble of removing the LED and replacing it. And when it turns out, it was the battery. So I grabbed a different battery. This is the different battery. Plug that in, and we will plug that in. And you saw the one bright blink, and I heard the beep, and we're good to go. Here are the two batteries side by side, and we've got our multimeter here. And let's first check this one with the ground, and we have 8.891 volts, which is you know, fine for a 9-volt battery, especially going through a 5-volt regulator. Let's try this other one. 8.773 volts. So it's actually less voltage, but for some reason this battery is working better than the Walgreens battery. So let's continue on with the build. The next step is the LCD header. So 16-pin connector. Let's do a little test fit. Looks like it'll fit in either way, and there are some spacers. And what he wants you to do is put the short part in through here. Perfect. Let's get that glue tack in place. That solder joint didn't hold at all. I guess I missed the pin entirely. Well, that was a pretty easy diagnosis. Checking to make sure it's all aligned the way that I want it to be aligned. It looks good. Let's put the rest of the pins in. All right, looks good. Step 9. Place the faceplate face down and then put screws in pointing upwards. All right, then put a spacer on each one of the screws and then put the display on facing downwards. That way when you flip it over, you'll be able to see it. And then another spacer. And then we put the circuit board on with the speaker facing down towards the speaker grill. That seems to make logical sense, doesn't it? And then there she rests. And that actually lined our display header up perfectly. I didn't even think about it when I was sitting down the circuit board. My screwdriver set and a screwdriver bit. Then I'm just going to try and line it up a little bit more to my liking in the center of the holes there. That looks good. Okay, perfect. Next thing is to solder the pin headers in. Step 10 is to put the battery terminal holder thingy together, and they are marked positive and negative, so we want to respect that. Let's test this out one more time. All right, it works. Now we can peel the backing off of the battery holder and stick it to the faceplate. Let's double check that this will fit on, and it will. Perfect. And then we can adjust the brightness of the display with this trim pot right here. Okay, that looks good to me. All right, they give us feet for the enclosure. And then on goes the thumb screws. And that's the end. We got it all built. Kaiweets soldering iron did a fantastic job of building the Morse code trainer. And I want to show you a little bit about how this works because there isn't really all that much to it, which I actually kind of like. So it has this heat protecting case on the front end of it. And then when you turn it on, it comes in sleep mode and you press a button to wake it up and it starts to heat up. And it'll seek a little bit trying to find its level. I've got it set for 310. And there you go. It doesn't take long at all for this thing to heat up. And then the only controls you have are to adjust the temperature down or up. Hold one in and it just goes down fast. And I tried to hold the other one in and it goes up fast. And if we go back to the main display, you hold the right arrow up, it goes to sleep. And we're back at the display and we hold the left arrow. And it's just a quick temperature change. Let's try both. So here are some controls here. We have temperature unit, sleep time, sleep temp, child lock, handheld, volume select, brightness, calibrate. So there's temperature unit. I just held it long press. And now I can press back and forth and change the temperature unit. And now it's in Fahrenheit. And I like to run mine at 640 Fahrenheit. Looks like it tops out at 780. So let's go back down to 640, and then when you're done, you just put the cap right back on, and you're good to go. Let's take a look at the Morse code trainer, but first we need a paddle. All right, choose mode is training, free play, settings. Let's go into settings. Select volume, pitch. Let's go back to volume, select. Let's turn it up so you can hear it. So it plays a little sound so you know what its volume actually is. Settings, volume, pitch, 500. And again, it's playing that sound. There we go, 650. Words per minute, 18. Add character delay, key or mode, iambic B, iambic A, or straight key. Let's pick iambic B. So you can reverse the keys on the paddle if you're left-handed or right-handed, or forwards or backwards, whatever your preference is. Start keying. It's not bad at all. I didn't wait long enough. It automatically inserts a space if you wait long enough. Training, level 1, K and M. Let's select that. Preview characters. All right, there it's K and that's M. Receive training. Transmit training. Echo back. Let's do receive training. Decode by ear. 3, 2, 1. M. K. 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 There we go. TX training. Start keying. 3, 2, 1. I'll make a mistake on the last one. See what it says, 92% correct. And then it shows you what it was wanting you to do, and it shows you what you did do, so you know where you made a mistake. %, correct. Of course. Free play. Start keying. Do whatever you want. Cool. Yeah, I messed up. Going to training, level 1.
Level 2 adds R, level 3 adds S, level 4 adds U, level 5 adds A, P, T, L, O, W, I, dot, N, J, E, F, O, Y, comma, V, G, 5, slash, Q, 9, Z, H, 3, 8, B, question mark 4, 2, 7, C, 1, B, 6, X equals.
There's all 40 levels. And I was using the cwmorse.us paddle. And the trainer comes with a set of headphones so you don't annoy everybody. All right, I think these things are both pretty fantastic, the Kaiweets soldering iron and the Sparkgap Labs MCT-73. There will be links for both of these in the description so you can get some more info on where to get these or how much they are or what kind of other fun things that they can do. The soldering iron did the job. I was very happy with it. It comes up to temperature very quick. It has enough rear end in order to get the job done. What I was worried about, and this was the same thing I was worried about with the pine sill, which I reviewed up above here, is that when you dwell on something difficult, you know, a big ground plane or something like that, that it would lose its heat. But this thing is able to pull forth and get through the job. It can muster up and sally forth, whatever it is you want to call that term that, you know what I'm trying to say, but I can't say because this is a family program. And the Morse code trainer worked out fantastic. We did have a problem with the battery, so it also works out great as a battery tester in case you ever wanted to, use a very difficult battery tester. However, as a Morse code trainer, this thing is aces. I'm going to do some more Morse code practice with this thing. If you're wondering how to get started with Morse code right after you finish training on one of these things, then get on the air and do some parks on the air stuff, because it's scripted out and it's extremely easy to figure out what you're supposed to do. I've got a video right over here that shows you how to do it. I'll see you over there. Thanks for being awesome.